Hey guys, welcome back. So I was going to include this segment as a part of the previous video, but I decided that this subject deserves its own dedicated video. With that, let's get started. Before we wire the main service panel, I want to talk about ground neutral bonding when having two inverters in split phase with grid input. Always exercise caution and ensure the inverter is completely discharged before working inside any inverter. I am not an electrician. Always consult a professional if you are unsure about something. With that said, before I go on my rant, I'll just get to the point for the impatient ones out there. When you have two MPP Solar LV6548 inverters in split phase with grid input, you want to remove the ground screw in the secondary 2P2 inverter only and leave the ground screw in on the primary 2P1 inverter. And the sub-panel should be unbonded. If no grid input, however, you can use the same configuration or remove the screws in all inverters and bond at your sub-panel only. Remember, the goal is to have only one ground neutral bond in your entire system. Unfortunately, the user manual for these inverters do not speak about ground neutral bonding at all, so this subject can be quite confusing. I spent several days testing and researching in order to come up with the proper test scenario so I could show you. This will apply to the MPP Solar LV6548 inverters. Although you could apply the same testing principles to pretty much any inverter as long as you understand what type of bonding the inverters use and how the bonding is implemented inside the inverters. There are several different bonding implementations used in inverters. These include switched bonding / dynamic bonding, common neutral bonding, or unbonded / floating neutral bonding. These particular inverters use dynamic bonding. This means that when switching from off-grid to grid assist / bypass mode, the bond is switched between the internal inverter bond and the existing bond in the main service panel. I'm going to cover the off-grid mode first, and then I'll cover the grid assist or bypass mode last. My sub-panel supplied by the inverters is unbonded. We can test that using a simple continuity test. That means there's a circuit. That means it's open circuit. Closed, open. So we're looking for an open circuit. So we'll put the probe on the neutral, and we'll put the probe on the ground, and there should be no tone. We can also go from neutral to the chassis, no tone as well. So there's no connection from the neutral to the ground on this panel. That test was done with the ground wires on each inverter disconnected. Let's connect the ground wire on one of the inverters and see if we have continuity. Okay, so we're going to go from our neutral again to our ground. And now we have a bond. Same thing, neutral to chassis, and there's a bond. Also, neutral to the chassis on the inverter, there's a bond. The ground terminal lug on these inverters is physically connected inside the inverter to the chassis. There's no separate ground lug for these inverters. So these inverters contain pre-installed bonding screws which create the internal bond. Let's take a look at where the bonding screw is located inside the inverter. Always check with the manufacturer before removing any bonding screws. Always exercise caution and ensure the inverter is completely discharged before working inside any inverter. I am not an electrician. Always consult a professional if you are unsure about something. Here I have removed the cover from the inverter. Locate the square circuit board in the center of the inverter. You do not have to remove this board. The screw is located just over the top of the circuit board. Looking down on the main board, you will see some yellow rectangular capacitors. Near the label C59, you will see a ground symbol printed on the board. That is the grounding screw. Use a magnetic tipped screwdriver to remove the screw to ensure it does not fall inside the inverter. These inverters run primarily in off-grid mode, so the system needs a bond while in off-grid mode. That will be provided by the primary inverter. Okay, so I already have removed the bonding screw in the secondary inverter. The primary inverter still has the bonding screw. So the primary inverter is bonded, the secondary inverter is not bonded. I will use a basic multimeter to show you the difference between a bonded and unbonded inverter at the AC output terminals. So when doing these tests, it's always best to do them without the inverters wired up to the system. Otherwise, you're going to get weird readings. So no AC input wires, no AC output wires, everything disconnected. It's best to do it when they basically come out of the box instead of after the fact. Okay, so for these tests, you want to have the inverters on, and we're going to be looking at the output voltages on the AC output terminals. Pay attention to the meter output on the multimeter and the socket tester here. We're going to test the bonded inverter first. So from probing from the hot to neutral, we should get 120 volts. Hot to ground, we should get 120 volts. And from neutral to ground, we should get 0 volts. 0 to 5 volts. Pretty much nothing. That's for the bonded inverter. Now let's perform the same test on the unbonded inverter. From hot to neutral, we should get 120 volts. From hot to ground, we should get around 60 volts. We're getting 50. And from neutral to ground, we should also get about 60 volts. We're getting 71. So we can see this inverter is unbonded. Okay, so since these are in off-grid mode, both inverters need to see a bond. So how do we get the unbonded inverter to see the bond in the primary inverter? Well, if everything is wired up, it will just work. But for demonstration purposes, I'm going to connect the neutral to the panel on this inverter, and it should pick up the bond from that inverter. Okay, so now I've connected the neutral back to the service panel, so these inverters are connected together now. I'll flip the breaker, and you can see here from our socket tester, we picked up the neutral. Let's test the output terminals. This should read exactly like that inverter now. It should read as a bonded inverter. Hot to neutral should be 120 volts. Hot to ground should be 120 volts. And ground to neutral should be 0 volts. So now this inverter is bonded through that inverter. Okay, so now that both inverters see a bond in off-grid mode, let's test the ground-neutral bond. I've connected the ground wires in each inverter. So this is exactly how it would be if it was actually a running system. Let's flip our main breaker. And we can see on the outlet tester that we have a good ground-neutral bond. Now I happen to have GFCI breakers installed right here, so I can actually test that by pressing that little button on the outlet tester. Let's go ahead and do that. Now the breaker tripped. Let's reset our breaker. And now we know we have a properly functioning ground-neutral bond. Here is a chart showing the voltages for bonded, unbonded, as well as my test results. Okay, let's see how the inverters behave when in grid assist or bypass mode. I've temporarily disconnected the AC input wires, and I replaced it with an extension cord. I hardwired the extension cord into the AC input so we can plug it into the wall, plug it in and plug it out so we can quickly connect and disconnect the AC input. Okay, so here's the outlet we'll be using. It's just a 20 amp outlet in my garage. I'll plug our outlet tester into it. And we can see we have a good ground neutral bond. And this is coming from the main service panel. Let's see how the voltages look on the AC output side when the inverter is in grid assist or bypass mode. It should look just like the bonded inverter. Okay, for this test we want to pay attention to the display on the inverter, and we want to pay attention to the multimeter here. The inverter is currently in off-grid mode. We're going to connect the AC input. Watch the display here. Now the AC input has been detected. Now we need to force the inverter to go into grid or bypass mode. To do that, we just shut off the battery to the inverter. Okay, the inverter has went to bypass mode. Let's check our voltages. It should look just like the bonded inverter. Hot to neutral, 120 volts. Hot to ground, 120 volts. And neutral to ground, 0 to 5 volts. We're getting 0.8 volts. So perfect. It's using the bond in the main service panel. Now I'm going to demonstrate the dynamic bonding in action as we see the inverter transition from unbonded to bonded when switching from off-grid to grid mode. Okay, for this test we want to pay attention to the display and we want to pay attention to the multimeter. Currently we're in off-grid mode, so from the neutral to ground, we should be reading 60 volts for unbonded. And there we have it, 53 volts for unbonded. Now let's go ahead and flip the inverter to grid assist mode, bypass mode. Now watch the meter, watch the display. Now we should go from 60 volts to about 0 volts. And look at that, 0.7 volts. We're in bypass mode. We're going to do one more test. We're going to test the hot to ground. It should transition from 60 unbonded to 120 bonded. I got to reset the inverter. Go ahead and plug in the grid. Okay, grid icon's on. Now we're going to probe from the hot to the ground. Okay, hot to ground, unbonded, we're reading 60 volts while in off-grid mode. We're going to switch it to grid mode. It should go to 120 volts. And there it is, 120 volts. And we're in bypass mode. So it's working perfect. Let's do one more test. I'm putting a lot of abuse on my inverters for you guys, so hope you appreciate it. I'm not supposed to just randomly connect the grid and disconnect the grid and connect the battery and disconnect the battery. But that's how we learn. Alright, so this final test, we're not going to use the meter, we're just going to pay attention to the outlet tester over here. Okay, now we're going to flip it to grid mode. And we should get a good bond. There it goes. So yeah, it's working good. That's how it should work. Yeah, so this video was a bit long because dynamic bonding is not the easiest to deal with. I wanted to show it working in real time, and it was for my own understanding as well. Reference videos I sourced during my research can be found in the description below. Of all the bonding types, common neutral bonding is the easiest to deal with. You simply let the main service panel handle the bond. There's no thinking. In this type of bonding, the AC input neutral is directly connected to the AC output neutral. Inverters such as the EG4 18K PV use common neutral bonding. Link in the description below. Everyone's bonding requirements may be different depending on equipment used, system design, and local regulations. That's all I got for this one. Questions or comments, please leave them below, and thanks for watching.